Hi, this is Casey Burns, flute maker from Kingston, Washington, and I want to demonstrate my rose engine attachment for the Lathe. I use these for making little silver discs that are engraved, which I inlay into the end caps of my wooden flutes, and I use it for other bling occasionally. I took a wonderful course from Brittany Nicole Cox in January last year, and learned how to do this. I also then took a 2-day course that she co-taught with the rose engine maker David Lindau in Pennsylvania. The technology comes from the Renaissance. And our first documentation of this is in the late 1500s, and it is similar to something that's called ornamental turning. This is called engine turning or gauche, and its primary use is for engraving on metal. If you're an ornamental turner, the big difference between this and like ornamental turning in wood is that you use a much lower amplitude on your rosettes. The parts of this, for me, I wanted to make something that would work on any lathe. So I have my metal lathe that I use. The metal lathe is not required. You can use a woodworking lathe. The only requirement is that you have a faceplate to mount all of this onto, and there's a faceplate behind here that you can't see. The spindle assembly, I have a base plate, which I use as a hand wheel. There are a bunch of cams called rosettes, and the rosettes have different patterns that are cut into them. You can buy engine turning rosettes. David Lindau sells a set of 6 rosettes for $150, which is very reasonable, made out of polycarbonate plastic. I've been making my own out of bronze with the assistance of a friend of mine who has a nice CNC shop. So mounted on the front of this is a Sherline rotary table that allows me to change the position of the work with respect to the rosette, and then of course a little 3-jaw chuck which I use to hold the work. The heart of my system is really this table. Most rose engine lathes oscillate in this direction using a headstock mounted on a pivot, and they're very, very heavy and massive so that their operation is smooth. This rotates very nice and smoothly just because the lathe behind it is massive, and what I did is trade the oscillation of headstock and put it to where my cutting tool is, so it's my cutting tool that oscillates back and forth. And that is done by 2 linear bearings that I have mounted between the lower plate, which is clamped to the lathe waist, and this upper plate that has the cutting tool. Mounted on the upper plate is a little tower that has what are called touches or rubbers that look like this, or here's one that I made out of wood. Right now I have a wooden one here that reduces my amplitude. Mounted to here is a little cross slide from, or compound slide from an old Sears Atlas 109 lathe that I bought on eBay. Mounted on the top of this and clamped to it is another little linear slide that has a cutting point that's mounted on it. So anyway, let me show you how I engrave. I need to make sure that my machine is all set up correctly, that I'm zeroed in on my dial here and zeroed in here. I'm going to do a pattern very similar to what's on this disc, hopefully. And you know, sometimes you get a different result than what you're expecting, but so we shall see. I'm going to do 2 ticks here and 2 ticks here for each cut. So let's make the first cut. Oh, and before I do that, I'm going to make sure that my work is well fastened to the chuck. Otherwise, you start and then the piece starts slipping and you lose your design. So how I do this is that I simply push the cutter, which I make sure doesn't run into the tooling first, and I push the cutter in while rotating this by hand. Okay, I was a little far out, but that's okay. Okay, I've made my first cut. So now I'm going to go 1, 2, at the same time do 1, 2, and do another cut. Okay. 1, 2. It's very important to count audibly because it's very easy to get distracted and then lost. And for demonstration purposes, that's okay, but I intend to use this piece on a flute later on today. 1, 2. So this cuts a fairly fine line. If you read the book Clockmaking by Daniels, or read Callie Shevlin's book called Gaucher, or Talk to a Gaucher, you'll see that there's this whole orthodoxy about how your cutting tool should be sharpened and such. And most engine turning is done with what's called a guide or guide, that is a little tool that limits the depth of the cut. The cutters are usually quite steep so that they'll cut deeply. I just wanted to see if this worked, so I just rough ground the cutter, approximated the angles that I needed, but I left it rather oblique on the end. And what I discovered is that I don't need a guide. It self-limits its cut. It cuts to a certain nice line that I like, and then pretty much stops. So you can see the pattern is starting to develop. So 1, 2, 1, 2. Now notice that I'm just using my hand on the rotation of this. Most large ornamental lathes or rose engines, they're all hand driven. They're not motor driven. And they're usually set up with a belting system, 2, that allows for very smooth motion here. But on most rose engines, the headstock is quite massive, and it requires some torque to get it to rotating. My system, because you don't have all that mass in the headstock spindle itself, it's just easy to rotate it by hand and simplest. I may end up eventually doing a crank, because this motion can sometimes be irritating to the tendons in this part of your arm. So, but for now, this has been working well for me for almost a year. Okay, pattern is developing nicely. So why did I develop this? I love the craft, but I could not afford to go out and buy an expensive lathe. And also I wanted to come up with a design that anyone could do this and not spend a bunch of money and time having to restore an antique machine, or simply affording one of the expensive new machines. The new machines, especially the ones that David Lindau makes, are absolutely gorgeous. I don't think I phased that, so let me phase it. And even if I did, it won't be that noticeable. Yeah, so what I'm doing here is that I'm advancing the cut to the next position, and then this I'm rotating the piece here so that the cuts aren't just pointing to the center. There's a little bit of an arc to them. So, David's lathes are absolutely wonderful if you can afford one, and I urge you to go that route. But if you're just a normal wood turner or metal turner but are interested in that, you can build this attachment to yourself. The design, some of the tweaking is figuring out where the positioning of everything goes. I'm eventually going to post on the internet a little pamphlet on how to make this, and with measurements and such and guidelines. And rosettes, you can buy rosettes from David Lindau. He sells a set of engine turning rosettes for about $150 for 6 different rosettes that are all basically the same shape, just more teeth per rosette, starting from 24 and going up to 96. And they're okay. They're a little bit uninteresting to me, because they're all the same shape. So, the other alternative is to make your own rosettes. It's nice to have a milling machine with a rotary table to be able to fly cut shapes out of discs. I have a friend who is making some simply by drawing them and then cutting them out on a bandsaw, and then working with files to refine the shape. He's doing those out of acrylic plastic. Polycarbonate plastic is used. It's a little bit better wearing and such. I'm going to stop the video now and continue it into a part 2 so that this video isn't too long for YouTube.